What we're going to be taking a look at right now is how we can influence ecosystems with other objects in order to directly impact ecosystems and specific objects are assigned to. What I have in the scene is a terrain object and a building. Now what I want to do is assign an ecosystem to the landscape, and I want to make sure that it doesn't populate within this building. I also want to be able to create the control to have a fall off kind of fading into around the building. So there are different ways we can achieve this, and we'll take a look at sort of the direct cutoff method first. Now what I've done is created an object that outlines basically the bottom of the object. So this is a very basic object in itself. If you take a look at just the object, it just outlines the outer part of the building. So what I want to do to start with, because I don't have it scaled up very high, is I'm going to scale the Y to say 5 meters and just make it intersect with the terrain. So what I can do is select the landscape and also select the floor object for that building, and now go to populate the object and add in, let's go ahead and add a plant. And let's use some trees. And I am working in the centimeter mode, so in order to get the correct scale, I'm going to have to bring it up to 10. And I'm going to edit my options really quick. Set it to billboards. Let's go ahead and change the number of instances to 10,000. I'm just going to go ahead and clear that ecosystem because I haven't done much with it, just so that I don't have to go through and modify the display qualities or anything of the objects. Now right now what we're seeing is that, of course, the floor object is being populated. What we need to do is either turn off the floor from the render in order to, or the viewport, to hide those objects, but we're still getting a little close to it. So this is just, that would probably be set up better for plants. So I'm going to go back, clear the ecosystem. I'm going to create a duplicate object of the floor because I do want to use that other object for a more advanced function. So I'm going to create a larger version of the floor. So I'm going to switch to the top view, Alt S to center, and so I'm going to go ahead and change the camera to the bottom and select polygon mode. Going to the rectangular selection tool, I'm going to turn off only select visible elements, and I do have this object rotated, so I'm going to need to just modify a few things differently. But I'm just going to pull out the sides to the front and the back. And what you can do is switch to the move tool, right click, and just make sure that you have the right option selected. So take a look, down here we have axis, and then we can change the world, the object, root. So just making sure that axis or object is selected. What we can do is add, so just holding down Shift and adding those other polygons, and just squish those together, or close together. And then take those polygons on the end, move them back. And these ones we're just going to pull out. And then move those ones forward. And take the back polygons, and we could just move them all back. And then we just need to move the sides. And actually, we probably could have just scaled the whole object outward. So just switch to the model mode, and now I can just stretch it out. So the scale of the object is going to determine how close we're going to populate to it. So we'll select the floor, landscape, go to populate the ecosystem, add in plant, I'm going to change the scale to 8, populate. So now if we go to the floor, now we can turn it off, and we'll see that the objects aren't coming nearly as close. And with something like this, what I'd end up doing, instead of further modifying the object, just going into the ecosystem, selecting the painter, and then you can go to the eraser and just kind of remove anything that is a little too close. That works pretty well. Another option, if you just want to remove the instances altogether, is if we go to that floor object and just select it by itself, and go to populate objects, it's going to give us a dialog that's going to ask us whether or not we want to edit the population for both objects, so the full ecosystem with this object, or whether or not we want to split it and create a new population. So if we select split and clear, and remember it did show the 5 instances that were on the object, but we can clear it out, click OK, and now there is no longer an ecosystem on it. So that's one way to kind of create an object for the population to make sure it's not part of a specific area using geometry. There are more advanced methods as well. So you can create much more complex setups. Although this method works really well, it does lack a fall off because it's, unless you just have intersections within the terrain, what you could do is have an object with a lot more polygons that's going to go up and down throughout the terrain, and that will create more variation. But there's an advanced function we can set up for this, a nice control for distance to the object below. So for this method, what I'm going to do is clear the ecosystems again, and we're going to go back to the original floor object I created. And I'm going to copy and paste and call it floor under. And if you just want to take a look at this object, I believe I saw some polygons in here that I did not actually want. It looks like I ended up creating some side polygons. Basically, when I extruded, I created caps, which I didn't mean to do. So those are gone. And what I'm going to do is take the bottom. First, I'll just go ahead and scale the model a little bit. And just move those polygons forward a little. What we're going to do is go to the bottom polygons. So we can switch over to a side view. Use the rectangular marquee, the rectangular tool selection, which still has the only select visible elements checked off. What I like to do is almost always have that option for every scene I work in turned off, and I can always switch to that tool in order to select everything. And then if I want to do individual selections, I can use the live selection tool. So our goal with these bottom polygons is to taper out the edge in order to give us the fall-off range that we need. And actually, now that I think about it, unless I want to populate only around this object, I am going to need the top set of polygons and not the bottom. So I'm going to take these and I'm going to use the normal scale and just scale them all up until they're almost all intersecting. We could square it up a bit if we wanted, and then I'm just going to scale it to the furthest edge, basically, of the fall-off. So where the subtraction is going to start, and then our bottom right now is set up to be where there's going to be nothing showing. So I'm going to move these polygons up, and then take the whole model and just move it down below the terrain. So making sure that no parts of it are sticking through. So now if we select the floor under what we just made with that nice taper and select the landscape, we can go into Populate Objects, add in a couple of objects, and we'll just use cherry trees and maple trees. And what we're going to do is control either the density or, and actually I do need to change my scale. It looks like I'm having a bit of a draw error here with everything showing up white. So I ended up just reloading the scene and just reapplying that in order to get the billboard mode working. So what we're going to do is decide whether or not we want to control density or control alpha. So basically working with the mixed material as I showed earlier in the training in order to create an alpha. Let's just go ahead and control our density with this. We're going to edit the function, and what we want to do is right click, add an input node, and we're going to choose the distance to the object below. We're going to set our distance unit to meters. And then we're going to connect it to the density. And we're going to set up a map filter. So we're going to add a filter, set it to map, and our output range we're going to set to -1 to 1. We're going to clip the out of range values, and now what we want to control is the input range, lower and upper values. we're going to extract the lower value, and we're going to name it the distance. And then what we're going to do next is control our falloff. And we're going to use this distance input to automatically offset the upper value by the falloff amount that we wanted to find. So we're going to extract this number, and what we'll do is call this falloff. And we're going to add in a combiner node and change it to add. And we're going to add the distance to the falloff. So distance and falloff are combined, and then we're going to disconnect that from or the upper value from the falloff to the add. So now when we set our distance, it's going to set or add that to the falloff amount. What we can also do is extract these parameters or publish them. So we'll call this in the decay, we'll call it a decay, and set distance, and we'll publish this within the decay as the falloff. So now when we go into the publish parameters, we can set our distance. So at what point do we want the transition or the decay to start? It has to be into the distance of the object below it. So let's go ahead and start with say 10 meters. And our falloff is going to be 10 plus whatever we enter in the falloff. So if our falloff is 20, then we're going to see that falloff range extend to 20. Set it to 50. Maybe reduce our distance a little bit. Go ahead and click OK. Just for now, what I want to do is take a look just at the object and see how large it is. And it is 19 meters. So our range is basically going to be about 20 meters. So if we go back to the object, we can start with a distance of 1, and have our falloff be 20. And as we increase the overall density, we'll see this a little clearer. So that's a nice way to be able to control this falloff amount. Now, if the distance is too high, obviously if we start with a distance of 20, that's going to be the full range, which is going to give us a very harsh cutoff. The falloff amount, I don't even think would matter at this point, because we've gone beyond the 19 meters. Also, taking a look, since we are in the negatives for the distance, that can modify and change the way that shows up too. So we want to be at least 0 to 1, if it's as close as I currently have the object. So it gives us a really nice transition range. So now if we go over to the density, and the overall density, we can start to decrease the overall density amount and see the falloff a bit better. We can cut it back by changing the start range, say 5 meters or 6 meters. Bring it down to 2. And adjust our transition just by raising up the number or lowering it. So that's a cool way to be able to put lots of objects underneath the object and set up a decay that works pretty nicely. We could also modify the scale or pretty much anything else in this method or in this manner. If we go ahead and change scaling, now keeping in mind that a lot of the objects won't show because the way it's cut out. So if we turn off the density, actually I do need to turn on scaling. So now we're just seeing the scaling, which gives you a better idea of how the falloff is appearing. It'll be a little bit easier to see the falloff in the way that the size changes. So we could do 0 to 19, see something pretty gradual. 15 to increase that. If we go to 5 meters, the fall off is very sharp. If we want to raise that back, or pull it back, we can do that too. We can get a lot more control by stretching out the floor under object, or whatever we have underneath it to control this. Now if we go back and also change the density, we can have a mix of smaller objects and also the density change. Now if we want to be able to reuse this control, what we can do is go into our function, and I'm just going to remove the scaling for now, and I'm going to unpublish these parameters. Now if you do want to make these extractable, right now you have to type in a value to get the falloff, but if you want to connect this to another function, there's another type of constant node you can use. If you go to the constant nodes connectable constants, then you can choose, say, a constant number, and that you will lose the slider. Sliders are only available if you extract from a slider. But this way what you could do is take this number and connect that to something else to control the distance amount, make it even more variable if you don't want to type it in, and just replace in this case the falloff with a constant number, or replace the distance with a constant number. That way you can key it in, or you can extract it if needed. This one I want to have kept just kind of for keyed in. And what we're going to do is create a metanode that we can load in and use in different functions. So what I'm going to do is just clicking and selecting all of these nodes, and we're going to go up to the top and create MetaNode. Within the MetaNode, double click to open it. What we can do is publish the parameters to the outside of the MetaNode. So when you select the MetaNode, you'll see those options. So we can just set this up. So let's call this the Decay, just for the group. Distance. And then we'll do the falloff again. And then if we go into the map, what we can do is publish this as the decay output. And we'll put, we'll just call this low. And then we'll publish the upper value and call this max. So now we have these values, and here where we can set the distance, the falloff, the low, and the max range. Another thing we could do is go to the distance to object below and publish this as the options. So now we can change the unit as well. If you want to be able to reload this in, you can save the metanode. So I'm going to call this Decay and save it. And now the way my installation is set up, I can go to Filter Node, MetaNodes, and choose that Decay that I just saved out. And I am going to show you in the next section how you can set up your metanodes that way. And if you do own Azulfix Snowflake, which is for view, It's also compatible with carbon scatter. A majority of the tools, except the animation tools, will work with carbon scatter, and they can be loaded in 100% compatible. So they do kind of port back and forth between each other. But I want to show you next just how you can access those metanodes within functions, because it is incredibly useful. And Snowflake includes several hundred metanodes for controlling all different sorts of things. Some pretty powerful tools in there. And I'm going to show one more decay method. What I'm going to do is just clear out the ecosystem. We can hide the floor under object. We don't need it. Go to the landscape. Actually, one thing I am going to do, instead of using the floor under, is I'm going to go ahead and add just a cube. Go ahead and set my scale for it to, and I did accidentally scale with the object mode, which I did not want to do. So we're going to go into the size for the cube, and let's go ahead and set up 50. Actually, maybe we do 70, or let's do 150 by 150. And then we'll go ahead and do 10 on the Y. We're going to use this object to control a noise. So we're going to set it just below the object. We're going to go to the landscape, and we're going to go ahead and populate and add in just a plant. Let's just do the cherry tree, and that'll work just fine. So now what we're going to do is go and we'll control. Actually, we do need to increase the scale. Maybe I'll make them a little bigger. And this time we'll use the mixed material method for the distribution. Okay, to get the most power as we can out of the distribution function, I'm going to change the smooth blending strip to 100, which should give us full control, and basically remove the blending strip. I'm going to increase the density a little more from the main ecosystem, and change this over to the world standard mode for the mixed material mapping mode, and that way our distribution of material 1 and 2 is going to be based on the world mode. So we're going to go to edit the function, and the node we're going to be using is going to be a noise node, math patterns, tooth Gaussian. So now I'm going to change the preview 2D plane, and our terrain is about 456 meters, so if I set it to a kilometer, we'll see half of it. Okay, so what I want to do is add in an input node external dependency. What we're going to do is use the scale of that cube, or the size, to control the noise. We're going to set it to true dimensions, meters. And now remember that the scale we have is actually only half. The scale we're going to be getting out of the size of what shows now as a polygon mesh, because it has converted the cube to something that is editable and readable by carbon scatter. That amount is going to be normal. So what we actually need to do is divide the scale before it reaches the scale amount. I'm going to keep the wavelength at 1 so that the origin works. Actually, now that I think about it, because there is a problem with the origin, I'm going to switch this over to a fractal and remove the roughness, which is going to basically give us the same setting as the noise, except with some extra controls. I don't see the meters showing up, so I just want to double check and make sure this is set correctly. Okay, so our origin will work now. What I want to do is take and convert, so I do need to re-add the external dependency. Now it's called polygon mesh in here, so we'll select the size. And what we need to do is break this down to work as a number. Now, this setup I'm just going to show you just to have an overall scale. It's not going to change independently for the x and the y, or the x and the z. X and z in Cinema, and x and y in Carbon Scatter. What we're going to do is add a math node, vector operations, and we're going to choose the decomposer 3. What this does is it takes a vector input. We do need to change that to true dimensions, meters. And it's going to give us 3 numeric outputs, one for x, one for y, one for z. So we can take any of those and control the largest feature or the scale. So remembering once again that these are going to be double, so what I need to do is divide in half so we can add a filter, set it to divide by 2, and connect that, and we'll just use the x. And then we're going to go to the side, making sure that extract or show parameter connections is turned on in the upper left here, and we can choose the largest feature and connect it to that divide. So now the largest feature is controlled by the scale of the cube. And it looks like maybe the scale is off just a little bit. So I'm going to go ahead and turn off the true dimensions and see how that works out. And it looks like what is happening is it's just not giving us enough range. I am working in the centimeter mode, so I'm going to switch this over to centimeters. When you're keying in manually, it's a little different than when you're actually using an object in its true dimensions. So it looks like in order to convert this properly, we do need to set it to the centimeter mode to match the document. So right now it's using that size of that cube to control where this is being subtracted from. And since we're controlling just a circle, we can see that showing up. If we go back to the gain setting, I am going to decrease the gain so that we're staying within a value of -1 to 1, and that way we can get some fall off. So then we could also use the map filter, cut it out further if needed. Increasing the gain will work well for that too. Of course, we don't want to go over too far with the density. If we want, there are different ways to clip this out. A smooth clip works pretty nice, where we can adjust the contrast and the brightness, and then set our low and upper clip amount. So we can transition through it a bit further. Now if we want to reverse this, it's actually quite easy. We can edit the filter, and in the upper right we have a flip filter button. Click OK, populate, and now it's just going to populate within that noise. So that's pretty cool. We can go ahead and take the cube, switch to the object mode. I'm going to move it over to the side, and then go back into the landscape, populate the object, and it should be refreshing. It was for me earlier. And the reason why it did not refresh is I did not connect the position. So what I need to do is right-click, add input node, external dependency. We're going to choose that polygon mesh, which is actually the cube, and the position. Set up We'll go ahead and try meters for the position. We might need to change it. And what we want to do is modify the origin to be connected to that. And it looks like that is working properly. So for the scale, it can be a little bit different than the way the position works. Position works better with the meters, and then the scale is working better with the centimeter mode. So I'm going to go ahead and stretch this out a bit. Actually, they did do it on the Z. The X is what's controlling it right now. Go back to the landscape, populate the object. You can see that updating. So that's a really cool way to be able to control zones. That way you can, really depending on your system, you can only really display so much geometry because unlike Cinema 4D's instancing, which can move or have a scene be pretty fluid and allow you to put a lot of polygons in it, Carbon Scatter isn't quite as efficient display-wise for full geometry. You can still push it pretty far, though. But this way you could isolate an area by using a control like this, and a control object. So you can pinpoint and preview a small section to really see what the density is going to look like without having to render. Now I do want to note that the Z-axis for the position is also affecting this. So eventually if I do move this too far, select the landscape and populate, we eventually will get to a point where we're really not seeing the impact of the fractal anymore. What we're seeing right now is the minimum amount, because I do have that smooth clip set up. So I'm going to go ahead and just remove that for now. We'll go back to the gain. Just turn it up a tiny bit. So now nothing is showing up. If we go ahead and select this object, and we may need to close it out in order to get that to refresh. And now it's showing properly. So since the function is 3D, we have it's basically a sphere. It's not two-dimensional. It is a sphere that is showing up with a full gradient. So obviously if we move it too high on the Z, we're no longer going to see that sphere because it's going to move too far out of the way. If you want to force it into position, or just have it control the width and have the up and down axis completely null for the position, we can manually set that. Or what you can do is go to the wavelength and set the Z to 0. So we should be able to take the cube and move it pretty much anywhere we want. So up here, before it wasn't showing, go to populate objects, populate again, and now it's still going to show. So the wavelength, just by setting that to 0, it makes it null. So it's basically a flat plane, and no longer takes into consideration the origin of the Z and the up and down axis. Anytime you set a wavelength to 0, the origin is completely null, which includes any sort of object seed or vector seeds added as well. Anything on Z is null. Now if you are having issues with setting the wavelength to 0, which can sometimes happen, what you can do is instead just set the origin to 0 and force it to 0 by adding in a MetaNode vector operations decomposer 3, and then we're going to add another MetaNode composer 3. What composer 3 does is the exact opposite of decomposer 3. It takes 3 numeric inputs and converts it to a vector. So the XYZ. So we can connect that to the position, the decomposer. Now we have x, y, and z. All we need to do is connect the x to the x, and if you hover over it, shows you what you're selecting, and they're typically in order. The y to the y output, so we have x and y connected, and then connect that to the composer. If nothing is connected, the value is typically 0. So that is automatically setting our origin to 0. If you want to define it more precisely, you can add in a constant number, connect that to the z, and then if we want to, say, offset it maybe by 1, we could type in that value, or by 10, and that way we have a manual control over the up and down, and then a dynamic control over the x and y position. So that's another way to do it. Another way to force a projection in that way, without the additional breakdown, is to go to a math node, a vector operation, and projection onto a plane. You add this to the position input before reaching the fractal, and this also nullifies the wavelength pretty much on the 0, except with the origin can be modified. Lots of different ways to do the same thing and avoid restrictions by the amount of controls you have. Going back to the smooth blending strip, we can also control that transition by basically clipping away the edges. It's basically a contrast shader. Another way to get this direct control, but open up the other axes a little bit more, is to use a different type of filter. I'm going to go ahead and just get rid of some of this stuff for now. And we'll just keep a few options. Instead of using a simple fractal, we're going to switch to a filter and change it to the area demarcation filter. And what this outputs is a shape where we can define the area shape: circle, rounded square sharper, and a regular square, along with a smoothness, and then the area width and height. Since we're in the world standard mode, these are going to be values equal to the scale size. So what I want to do is set the interior value to -1 and the exterior value to 1. What that's going to do is take the shape and set that to -1, so a negative, and then everything outside the shape is going to be 1, so will be populated. The area center we can connect to that position for that cube, or showing as a polygon mesh. And then we do need another divide filter, because this one also doubles everything. Connecting that to the y, dividing by 2. So now we're going to control the x and the y. Shape, which means we also need to connect the width and the height. So we're going to extract the width, connect it to the x, extract the height, and connect that to the y. And then connect that to our output. Go ahead and move that down. And then if we go back into the populate objects, we can control the smoothness. So we can smooth it out on the edges if we wanted to adjust our transition. If you want to see how the different scales work on different axes, we can scale it. I'm going to scale it on, for the object mode, kind of move it over. We'll take a look at it first. Go into the landscape, populate, and move that under, and now we can see that it is stretched out properly. So we can stretch it out even more. Populate. And I did use the model mode to do that. So we will have to get it to refresh. And it looks like that is working a lot better. So we could also change the shape to a square. And then we can start to clip it with the smooth blending strip. So now it's directly controlled for the X and the Y. We can stretch it out further. Looks like it might be off a little bit. And it might be because the mode that's set up. And I'm just going to see what happens if I set the division to 1 to nullify. And it does expand it a lot more. And I think it's mostly just because of the smooth blending strip that's making it look like it's not lined up properly. It could also be a refresh error. So make sure you stick with that model or the object mode. And I didn't edit with the model mode, which is why the problem is showing up. But that's pretty cool. You can get a lot of control over your ecosystems with using other objects in the scene. Now, of course, it's not something that can be animated. It's not going to change your population over time, but it still gives you a lot of flexibility to work with. If we did want to reverse this, we can go into the area, demarcation filter, change the interior and exterior values, and flip them around. So now it populates within the box area. Keeping in mind it is smooth and it is expanding a bit more. Also, the way the gradient and the falloff is on the edges of this shape, since they're equal to begin with, then we are going to see more of a transition anywhere it's stretched out more. So this is also a useful method for creating LOD zones. And what you can do is we'll just take this current ecosystem and make this our high-res area. So go to the landscape and populate. And it looks like maybe that scale on the for the model mode is not refreshing entirely. That looks a little better. Okay, so what we'll do is we'll set this as high resolution objects. So going into the material, material 1, we're going to set the geometry quality to high, which it's already at. Then we're going to go, and we could just use the same material, copy the material and paste it into material 2. And we'll select populate the ecosystem. So now this is the opposite of the other zone, and what we can do is take material 2 and change the geometry quality to low. It won't be all that visually noticeable until you render, but if you have things set up correctly, then you'll be able to see high-res objects in front and low-res objects in the back. So by setting up the separate layers that way and controlling our alpha, we can control the detail level. And here's the render of that. And the transition works really well. It's not noticeable where the geometry quality really changes because it is far enough away. So that way you can have a nice high-level area, and then everything in the back that you're not very close to can stay nice and low res, anything where the camera's not going to get too close to it. And even with the case of trees, you can get pretty close to the tree leaves with the lower quality. It's really the trunks that change the most. To be able to access MetaNodes directly within the function editor in Carbon Scatter, there's a very simple setup for this. What you need to do is go to your installation directory for the content. This is going to include the plants, the functions, filters, and you'll see a pictures folder. And my backup folder that's custom. What you need to do is create a folder called MetaNodes, which I've done here. Within that folder, you can create a folder for every main group of node. Now, some of these I have are also found within View and not found within Carbon Scatter, so they won't show up in Carbon Scatter. If you take a look to find out which directories are compatible, what you do is open up the function editor, which I'm going to do just by adding an ecosystem, and going to the function. If you right click, every single folder you see, input, output, noise, fractal, texture map, filter, constant, turbulence, combiner, and math can all have their directory. So what you do is create a directory for each of those names, and then place metanodes within those directories in order to be able to access them. So we can see if we go to filter, once a folder is placed and called filter within the metanode directory, a new metanode pull down becomes available within the filters. So these are some of my filters from Azulflex Snowflake, the metanode collection. So as you create new metanodes, you can add them to these different folders to match what it is you're controlling, or wherever you want to put them. You can also load metanodes just by right-clicking and going to Load Metanode, which is going to open up the folders. And you can just browse to the folder in order to select different nodes. But I really prefer to just have everything directly accessible within the menu. Makes things go much quicker. And I've also got a whole lot of tools that I've created. So it makes it a lot easier to access them.